What is up, everybody? Welcome back to another live stream from Scalar Learning. And this is not the weekly Wednesday live stream where we do Khan Academy 5 questions for the SAT. No, today is a special edition. Why is it special? Because tomorrow is the day. Tomorrow's the day that many of you guys are taking the actual SAT. And first of all, for any of you who are taking it tomorrow and you're watching this live, I want to wish you the best of luck. And I hope you take time today after you watch this video to rest, relax, calm your mind, and be healthy, be nutritious, all that good stuff. And I really do wish you the best of luck. What today is about is, if you've been prepping or if you haven't maybe done enough prep or whatever it is, this is a last minute prep session for you guys. Everybody out there who's taking the SAT tomorrow. And it is all about how to boost your SAT math score by 50 points in 2 hours. And I know that sounds crazy and I know that sounds ambitious, but let me get into the presentation and show you exactly how I think this is possible, how I think you can make a big jump with just this quick 2-hour video. And by the way, first I'm going to give you some tips, 3 really key essential tips to maximize your performance on the SAT math section, and then we're just going to smash through practice problems. The practice problems are going to be super important because you're going to watch me in action, apply the tips and apply the strategies that I've given you. Watch me go through the problem solving process, and I'm not just doing it in a way that's not relatable. I'm taking it under time settings. So I'm doing them as fast as I can. You're going to see exactly how you can approach these problems and solve them in real time. And I think that's going to be the biggest benefit for everyone watching. So let's get started. Let's jump right in to our presentation here. Let me just do a quick sound check and make sure we're going. The biggest benefit. Yeah, all right. We are going. And let's get this set up over here. All right. So first of all, let's jump into it. Now, boost your SAT math score by 50 points in 2 hours. So sounds ambitious. So let's start. And first of all, how do you jump by 50 points? How do you go from a 650 to a 700? How do you go from a 750 to an 800? What does that even mean? So first of all, we need to understand what that means. That means just 4 more questions right. That's all you got to do. If you improve your score by 4 questions, that's a jump of 50 points. Now, according to this grid made by Prep Scholar, okay, on the Prep Scholar blog, you can kind of see how we see what's going on in terms of the relationship of the raw score, meaning the number of correct answers, and your math score. So it's really cool. Like if you look here, you can see if you go from a 20 to a 24, well, in this case, 20 to 26 would actually be, so 6 questions would be 50 points, but other places, it kind of varies. It's not all uniform, but like 54 to a 58, that's 4 points. That goes from a 750 to an 800. And other places, let's see, 650 to a, let's see another example that I saw before. Here we go. 50 to a 54, just 4 questions right when you're in these upper echelons. 4 more questions right can give you a jump of 50 points. Of course, it stretches out a little bit more down here, 38 to 44. This is more like 6 questions for 50 points. But in these upper echelons, if you're trying to eke out just a little bit more, just 4 questions. Even if it's just 5 questions, there's major ways that you can do that to experience that bump. Now I'm going to show you exactly how. And these are tips that you can apply tomorrow. If you're paying attention, you're watching me give these explanations and go through these practice problems, you can literally put these into action tomorrow. So let's jump into it. All right. So tip number 1, draw and write everything out. So this is super essential in mathematics to gain an understanding of problems, especially when you feel like you're getting stumped. If you have a diagram that's being described, or a square or a rectangle, draw it out. Or if you have a diagram that's out there, fill it in with whatever variables and numbers you're given. Just make use of, or start writing. A lot of times, what to do may not be there right away, but it'll come to you as you start to fill things out and write. Make sure to write down all equations and plug in every number that you can find. So just start moving in some direction. Plug in numbers into variables and see what happens. Even if you don't know where you have to go, if you start doing things, sometimes the answer the path will reveal itself. Finally, make sure to cross off any eliminated answer choices. You've got something, you can eliminate it down, boom, boom. You've just increased your odds of getting it right from 1 in 4 to 1 in 2. And now you have a substantially higher chance, right? So now out of 4 questions, instead of answering 1 question right, you're answering 2 questions right. So just by that simple strategy alone, you can double your chances of a lot of these questions where you're kind of confused by eliminating 2 choices, doubling your chances, right? So on 8 problems, if you do that, you go from getting 2 right to 4 right. Okay. Let's go tip number 2. If factored, foil. If foiled, factor. Okay. What does this mean? A lot of times when you see something already foiled, already factored in this case, you're going to go ahead and just think, well, I don't know how does this relate? I'm really confused. To be like, wait a minute. It's already factored. Let me foil it, meaning let me multiply. You're going to multiply this binomial and this trinomial and see what you get, and lo and behold, that will reveal the answer. Other way around, now this question here is specifically asking you to factor, but a lot of times you'll get a quadratic or some other type of equation. They'll say, what's equivalent to this quadratic? And then the onus is going to be on you to just start factoring blindly, and that's okay even if you don't know where it's going to go, but just do that as a matter of course, and that's going to get you really far. All right, the last tip number 3. If you start getting stuck, this is the biggest tip, most important tip. Jump to the free response section. Okay, so the free response section is huge, and it's so important because, let me back up. The free response section, the difficulty resets, okay? When you get to the free response, it's almost as easy as the first 5 or 10 questions of the multiple choice. So if you're struggling on question 25, 26, 27 in the calculator section, and if you have a low probability of getting those right because you're really struggling, don't do them. Just go straight to question 31. That's where the free response starts. And all of a sudden, it'll be like a breath of fresh air. The difficulty will be way lower. So now, instead of wasting your time and not getting to the free response, just knock out 31 through 34. Boom, right? Like right after you finish question 20, knock those free response questions out, especially if you struggle on the harder questions, and you'll guarantee to get those right. Then you can bounce back. But that's a key way to gain right off the bat 3, 4, maybe even 5 extra right questions if you're careful with this one. Where do the free response questions start? In the calculator section, it's 31 through 38. And on the no calculator section, that's questions 16 through 20. So those are huge. And just take these 3 tips, think about them, write them down, process them, and use them tomorrow. And I guarantee you, if you do these things right, you can see a pretty substantial jump just from a short little implementation of a few quick tricks that are really effective. All right. Hope that was helpful, guys. Now we're getting into the meat of this cram session, and that is the practice problems. What we're going to do now is we are going to blast through some practice tests. Now, the cool thing is these tests are real tests from Khan Academy website. They have a partnership with the College Board, so these are the best practice questions you're going to get, most authentic, most legitimate, and most closely related to what your actual SAT is going to look like tomorrow. So what we're going to do is I'm going to try and make my way through as many practice problems as possible, given the time restrictions on my schedule and what I have to do today. But we're aiming for about 2 hours worth of good, solid practice problems. Now, usually I like to do practice problems that I've never seen before, so it's more authentic. The thing is, Khan Academy only has 8 tests up there, and I've taken all 8 of them. The videos can be found on my YouTube channel. So I've taken all of these tests already, so now I'm kind of repeating. Last Saturday, I did test 1 and 2 again, just the math sections. And now I'm going to do test 3 and hopefully test 4, at least part of test 4. And you can watch along and see that what I'm talking about, it works in under-timed pressure in real-time settings. And you'll see exactly how you should be going through that same problem-solving process when you're taking the SAT tomorrow. So this is really about learning via osmosis. Watch me, watch what I do, and apply it, okay? All right, and I'm not just talking the talk. I've taken the SAT time, the real deal. I did it last year. And of course, I got a perfect 800 on the math, but that's, this is my thing. This is what I do, and this is what I study, and I want to impart that wisdom to you guys. So let's do it. Watch, pay attention, take notes, and again, best of luck. So we're going to jump in here. Let's go. Finish. Boom, because I don't care about the reading. We're skipping that. Next section. Let's go. Finish. All right, here we go. What? Oh, start the next section. All right. Math. No calculator. My favorite section of the SAT. So we're not using a calculator. You see I have this window over here. This is the calculator. We'll use that for the calculator section. 20 questions, 25 minutes, and don't forget those free response questions are at 16. But usually, because time is not an issue for me, I just go in a linear fashion and I get to them when I get to them. But for you guys, where it is a factor, don't forget that tip. Okay, ready, set, game time. A painter will paint N walls with the same size and shape and building, use a specific brand of paint. The painter's fee can be calculated from the expression N, K, A, H, where N is the number of walls, K is a constant with units of dollars per square foot. Okay, I'm just gonna write this down. And A is the length of each wall, in feet, and H is the height. If the customer asked the painter to use a more expensive brand of paint, which of the factors in the expression would change? This guy, which is K. That's it. With units of dollars per square foot. I mean, that's really all it is. So just keeping track of all those constants, which was kind of crazy. All right, what is the value of 6r plus 3? There's a couple ways we can do it. I'm just going to isolate. I'm going to solve for r equals 6. So therefore, 6 times 6 is 36 plus 3 is 39. Boom. That's it. All right, next question. Which of the following is equal to a to the 2/3 power? For all values of a, I'm going to convert that to... This is a rational exponent. We can convert that by saying this is actually the cube root of a squared. The root, which is the denominator. This is the power, which is the numerator. So it's that, and that is right here. Okay, next question. The number of states. Okay, let me just go back and make sure I didn't rush through that too much. Square root. Yes, that would be 3/2, 3/2 power. Yeah, we're cool. All right, next one. The number of states that join the United States between blah, blah, blah is twice the number of states that join between here. If 30 states join between in this era, okay, so the number of states that joined here is twice. Okay, so first one is 2x, the number that joined over here. If 30 states joined here, so this is 2x equals 30, then which of the following equations is true? It's this one, right? Oh, no, it's not. Sorry, 2x equals 30. If 30 states joined and x joined, yeah, this is right. Because it's x is 15, 2x is 30. Should be good. I'm going to have to go back. I'm kind of rushing through these, so I'll make sure I'm right. Okay, what's the value of x over 5? Here's what we can do. We can cross multiply. I mean, we can also take the... Now, you know what? I'm going to solve this. So I'm going to cross multiply. Okay. I've taken this test, but it was a long time ago, so these questions feel fresh. So it's 15x equals 5x plus 100. Subtract 5x from both sides, and we get 10x equals 100. X equals 10. Therefore, 10 over 5 is 2. Okay. Next question. 2x minus 3, okay, this is a solution to the system of equations above. What's the value of x minus y? All right, let's solve systems of equations. How do we do it? We can do substitution or elimination. I like elimination for this one because it's going to be kind of a pain to isolate any of these variables. So I'm going to multiply the top by, I'm going to knock off the x's. So I'm going to multiply the top by -3 and the bottom by 2. So we're going to get, the top one's going to be -6x plus 9y equals 42. The bottom's going to be 6x minus 6y equals -12. These cancel out when we add them up, and we get 3y equals 30, y equals 10. If y equals 10, then it's 2x minus 10 times -3 is 30 equals -14. And then add 30 to both sides, 2x equals 16 divided by 2, x equals 8. So it's y equals 10, x equals 8. What is x minus y? -2. Oh, wait a minute. Something has happened. I've made a mistake. Because x minus y, according to my calculations, should be -2. And that's 10. It's 8 minus 10. Okay, so what did I do wrong? Let me see. Positive 9y. Oh, this is 4y. That's why. See? Everybody makes mistakes. All right, so 6x, so this becomes 5y. And then that becomes y equals 6. And then we plug 6 in here. So 6 times, so this becomes negative 18, 2x minus 18, because I plug the 6 in for y equals negative 14. And then add 18, so 2x equals 4, x equals 2. All right, so then x times y is negative 4. Whew, okay, lost a little time there. Let's keep going. I got 21 minutes left. The function f is defined by a polynomial. Some x and f of x values are shown in the table. Which of the following must be a factor of f of x? Well, x minus 4. Because this tells me that 4 gives it a 0. Therefore, we should be able to factor out x minus 4. So x minus 4 is a factor. It's a little harder to explain that one, but the line y equals blah blah is a constant. K is a constant. Is graphed in the xy plane if the line contains point CD, where C doesn't equal 0 and D doesn't equal 0. What is the slope of the line in terms of C and D? Okay, here we go. So it contains CD, and we've got this function. I'm gonna start plugging in. This is a y value. This is an x value. So that means D equals like, and I don't know where this is gonna go. I'm just kind of following my instinct. D equals K. Actually, okay, now I know where to go. Now we want to know what the slope is. Well, the slope is always K. It's not always K. It's the value multiplying X. So now we want to isolate K. Subtract 4, subtract 4. We get D minus 4 equals KC. Divide both sides by C. Divide both sides by C. So K equals D minus 4 over C. Cool. Next question, kx minus, in the system equation, k is a constant and x and y are variables. For what values of k will this have no solution? When does it have no solution? When the lines are parallel, but not the same line. They're parallel and they have same slope, different y-intercepts. So I'm going to put both of these in slope-intercept. So we got the kx minus 3y equals 4. Negative 3y equals negative kx plus 4. Move that over. Divide by negative 3y equals kx over 3. Divide by negative 3. So the negatives cancel out. Minus 4/3. And then the second one is negative 5y. I'm moving the negative 4x over right away. And then dividing everything by negative 5. Oops. Negative 5. That should be a plus 7. Sorry. And then it's y equals 4 over 5 positive x minus 7 over 5. Okay. And now we say for what value of k will the system have no equation? Well, they obviously have different y-intercepts. So when will k over 3 equal 4 over 5? And then we solve. We need to know how is this going to equal. How is this side going to equal 4/5? So 5k equals 12, divide by 5, divide by 5. K equals 12 over 5. Okay, cool. Feel pretty confident about that. Then say xy plane the parabola. This intersects with the line with the equation y equals 25 at 2 points. What is the length of AB? Okay, so we got two. This is a system of equations again. It's just not linear equations. We want to know where they intersect. Well, let's set these two equal to each other. Y, let's substitute this in for y. 25 equals x minus 11 squared. Square root both sides. Square root both sides. X minus 11 equals 5. Actually, it's plus or minus. So then we add 11 to both sides, and we get two solutions. When x is positive 5, when this value is positive 5, x equals 16. When it's negative 5 plus 11 is 6. These are the two places where the lines will intersect. So the length of AB is just 16 minus 6, which is 10. I think that's right. All right, in the figure to the left, lines KLM intersect at a point. If x plus y equals u, okay, I'm going to have to draw this out. Whoops. X, Y, Z, T, U, W. And we know that, let's see, what does it say? If x plus y equals u plus w. So these two angles are equal. Let me put a little thing here. This is equal to this. Yes. So the following must be true. Okay. Let's see here. So let's make some assumptions first. Y. So we know Z equals W. We know that. We know all the vertical angles are equal. If these two are equal, we know, oh, I know what we do. Since we know that Y and U are equal, if these two larger angles are equal, X and W are equal. So X equals W, Y equals U, obviously. And then that means these two are equal. We already, well, I'll just assume we know that all these vertical angles are equal, but that's fine. Then we know that X equals Z, because W equals Z and X equals W, so cool. And since X equals T, W also equals T. Right, these are just some things I'm throwing out. And now let's look and see. X equals Z. Yeah, we have that. 1 is true. 2, Y equals W. I don't think we know that. Z equals T. Does Z equal T? Hold on. I don't think we know that Z equals T. All right. So, somewhere there's a mistake. So let me see. X plus Y equals U plus W. Do I know that? So maybe, and then Y equals W. Let's see that one. Maybe that one is true. These guys equal each other. Y equals U, and then this plus this equals this plus this. Therefore, this equals this. Uh-oh. I'm kind of stuck. Z equals T. How many times? 14 minutes. Does Z equal T? Z equals W. X equals T. Shoot. I'm not sure. Obviously, the fact C is out, so we can eliminate C. It's either D, B, or A. But I feel like I've made a mistake. Like I can't rule out. Oh, what am I doing? All right, I'm about to skip this question because I think I'm wasting so much time. Y equals, does Y equal W? But because of Y equals W, it means that all of these have to equal each other, right? Because we already know that these equal each other, and therefore these X must equal W. Okay, and we also know that Y equals U, Z equals W, and Z equals X, X equals T, W equals T. Let's see if I can work anything out here. So what was that? Z equals T, Z equals X equals W. Oh yeah, 3 is right, because Z equals X, X equals W, W equals T. So 3 is definitely right. So it's either 1 and it's either B or D, and then does Z equal T? I'm just gonna roll with this for now. Z definitely equals T. I just have to figure out later. Okay, so I'm gonna come back to question 11. Okay, cool. Oh, that was bad. 13 minutes left, no good. All right, in the quadratic equation above, A is a non-zero constant. The graph of the equation XY plane, parabola vertex CD, which following is equal to D. All right, so it's got a vertex. Oh, okay. So we have vertex, so we have the y-intercepts. All right, I think I have to, I'm like a little bit now off track because of that last question. So let's just, I'm going to FOIL this. I think we have to get into vertex form. A times x squared plus 4x minus 2x plus 2x minus 8. And then we do, I have to find equal to D. So we want that D value, then I'm going to be like x squared plus 2x. Half of this plus 1. I'm kind of going fast now because I'm really lost a lot of time here. Yeah, oops. A, and then that completes the square, so I'm adding 1, so I got to subtract 1, so minus 9. And then I've got A times x plus 1 squared. Okay. And then minus 9a, so it's minus 9a. 9a, this is, I put it into vertex form, and I FOILed it, then I completed the square, and I did all this, and that value out here is the D of the vertex, so it's negative 9a. Okay. Next is this and this, where a is a constant. What is the value of a? We have this equals this. Okay. All values of x. Okay. So again, this is like a crazy problem. My first instinct is to, let's see. Okay. I'm going to put everything over ax minus 2. So that I'm going to multiply these guys, negative 8x times ax minus 2 minus 3 times ax minus 2. And now I've put everything, because this will make it over ax minus 2. This will make it over ax minus 2. So everything is now over ax minus 2. So all these denominators go away. Okay, all of this goes away, all this goes away, these go away. When you're all over the same denominator, they're meaningless. So now we have a new equation, 24x squared plus 25x minus 47 equals this. I'm going to distribute it. Negative 8ax squared plus 16 minus 3ax plus 6 minus 53. So these guys combine to become, I already know what a is. A is negative 3. Because the only way to get these two terms to equal each other, a has to be negative 3. Okay. So close to the free response. What are the solutions to 3x squared plus 12x plus 6 equals 0? Let's do a little quadratic formula. I assume it's not factorable because of all these answers have this. So it's, and I'm going to divide everything by 3 first. So it's x squared plus 4x plus 2 equals 0. Much easier for the quadratic formula. We could do that. We could divide both sides by 3. Now we have negative 4 plus or minus the square root of b squared, which is 16, minus 4ac. 4 times 1 times 2 is 8 over 2a. 2 times 1 is 2. And then it's negative 4 plus or minus the square root of 8 over 2. And then we can factor out, we can pull out a, this is like 2 times the square root of 4, so simplify becomes negative 4. And then the square root of 4 is 2, and we have a 2 remaining inside over 2. Divide everything by 2, and we get negative 2 plus or minus square root of 2. Right here, negative 2 plus or minus square root of 2. Done. Okay, one more hard question, and then it resets. In the equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature, Celsius or whatever. Based on this is a real equation for conversions. Based on the equation, which of the following must be true? A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 Celsius. So let's do a simple test. If I have my Fahrenheit at 32, Celsius is 0. 33, this becomes 33 minus 32, which is 1 times 5/9. Yes, the temperature is increased by 5/9. So 1 is true. 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 Fahrenheit. That's a little tougher to show. Let's see. We can just isolate C, or isolate F, so then it becomes 9/5 C equals F minus 32. 9/5 C plus 32 equals F. And so we can say a temperature, yes, actually this is right, because if this goes up by 1, Fahrenheit increases by 9/5 because it's multiplying by 9/5, and that is a change of 1.8, so that's good. And then a temperature increase of 5/9 degrees Fahrenheit is equivalent to temperature. If this is true, this has to be wrong, because this is saying the reverse, right? So a temperature increase of 5/9 of Fahrenheit. So 1 degree, we already know 1 degree Celsius is 9/5, so that's out. So it's 1 and 2 only. Okay, next question. Yay, now the difficulty resets. 7 minutes, I can do it. All right, what is one possible solution to the equation above? So we've got, I'm going to just remember, I don't really know what to do here, to be honest. So I'm going to, wait. 0. Actually, oh no, it's got to be greater than 0. Okay, I'm going to FOIL. So it's x to the 5th minus 5x cubed. And then I'll add 4x to both sides plus 4x equals 0. And then I'll factor out an x from everything. It becomes x to the 4th minus 5x squared. Like, I literally don't know if this is the right approach, but I figure I'll figure it out as I go. And then I can factor this guy, just as if it were quadratic. This would be x squared. Yeah, this works. Minus 4 minus 1. What multiplies to 4 adds to negative 5. Boom. So now one possible solution that's positive is right here is 2. 2 would make this whole thing go to 0. 1 would also work. So either of those answers will work. And if you don't believe it, you can try it. 2 in here makes -8. 2 in here makes 4 minus 5, which is -1, times 2 cubed, which is -8. So -8 equals -8. 2 works. Next. What is the value of x? So let's solve. First of all, 7/9 minus x minus 4/9 x equals 1/4 plus 5/12. I don't like the fraction, so what's my common denominator of 4, 12, and 9? It's 36. So I'll multiply everything by 36. This would reduce to 4, so this becomes 28x minus 36 divided by 9 is 4 minus 16x equals 36 divided by 4 is 9 plus 36 divided by 12 is 3 times 5 is 15. 28x minus 16x is 12x equals 9 plus 15 is 24 divided by 12 divided by 12. X equals 2. Do you need to do that? Do you need to get rid of the fractions? No, but it makes life a lot easier. Okay, 5 minutes left. We're doing okay. 2 isosceles triangles are shown to the left. If that is true and y equals 75, what is the value of x? So I'm going to redraw it over here. You don't have to do this on the real test because you have the diagram that you can draw on. Okay. So we know that y equals 75. We know that these two are equal. Oh, right off the bat, 75, this is isosceles triangle. So guess what? This is 105 are these two. So this is 52.5. 52.5. I don't know if that helps us. And we know that z over here is something. We don't know what z is. We want to find x. We know that these two values here are, these angles are supplementary with x. So we know that, okay, so let's do it like this. 180. Oh, we just can solve it. 180 minus z equals 2 times 75, which is 150. So z is 30. So this is 30. Then this is isosceles. So that means this is 150. These are 75, 75. And this is what plus 75 equals 180, 105. I think I did that right. Don't really have time to check it because we've got 4 minutes left. Okay, at a lunch stand, each hamburger has 50 more calories than fries. Okay, hamburger has 50 more calories than fries. If 2 hamburgers and 3 fries, I know this is a system of equations, has 1,700 calories, how many calories does a hamburger have? We're solving for h. System of equations, done. We just substitute this in for, no, let's do it the other way. Subtract 50, h minus 50 equals f. I'm going to substitute this in for f, and then we can straight away solve for h. 2h plus 3 times h minus 50 equals 1,700. 2h plus 3h minus 150 equals 1,700. And then we add 150 to both sides. Okay, I got to go faster. This is 5h equals 1,850 divided by 5 divided by 5. It's like dividing by 10 and then multiplying by 2. So it's 185 times 2 equals 370 calories. Okay, let's just roll with it and we'll come back later. We have 2 minutes, so I can't do anything. Don't even think I won't be able to finish, I think. Triangle ABC, measure of B is ABC. B is 90. I don't know, AC. BC is 16. AC is 20. DEF is similar. So here's E90, DF. Respectively, in each side of triangle DEF is 1/3 the length of the corresponding. So this is 20 over 3. And then BC is 16, AC is 20. Okay, what is the value of sine of F? It's this over this. But sine of F is the same as sine of C. Okay, so this is, hold on, 16 squared plus x squared equals 400, 256. Okay, x squared is 400. I already know x squared is 1. This is 12. Squared equals 144. X equals 12. And then, so sine is opposite over hypotenuse. So 12 over 20, which is 6 over 10, which is 3 over 5. Okay, I don't really have time to check because basically the sine of any angle is the same. It doesn't even matter. We don't have to fill in these values. I'm sure we'd get the same thing. There was one that I was kind of confused on. Let's look at 12 or 11. All right, if x plus y, okay, and then we were just debating whether 2 was true, and I think y equals w. I don't think we could show that, right? Y doesn't equal w because x and yeah, I think it does. Wait. I'm gonna go for it. Y equals w because we showed that x and u equally. No. I'm gonna stick with my guns. Oh no! I tried to switch it back to the one above it. All right, let's see what I got. Darn it! I bet you that's the one I got wrong. Oh, I'm gonna be so mad. Oh, yeah. If I would have just left it alone, I would have had it. Those two were right. It was 1 and 3. So somehow it took this answer. It took the 1, 2, and 3. So it was. I should have just left it as is with just 1 and 3. Okay, so that's a bummer. So this one was the hardest one for me, and maybe my strategy wasn't the best, but I was trying to unwind it by using my understanding of what's it called, vertical angles, and then the equation that they gave us. But yeah. So anyways, the time was a little bit mismanaged there. Obviously, this is the tough thing here is obviously if you just are doing the problems and not trying to explain them as you do them, you can go way more quickly. So that's part of the reason why it's hard for me to actually go at that, you know what I mean, at the realistic pace in terms of if I were just taking it. But that being said, you know, the strategies worked. We still got pretty much through the whole thing within the time, save for that one question that was incorrect. So it is what it is. All right, sweet. Let's finish that and let's go on to math section, calculator. And we got our calculator open here. Let's just see if there's anybody asking questions right now. Yes, we got some questions here. Let me take a look. All right. What did you get beyond? Oh, they're talking. You guys are talking to each other. Okay. Cool. If you're not ready, Daniela, then this is why I want you to watch, because I want you to watch and I want you to learn, hopefully, some new things as we go through all these problems. Okay, let's go back here. We're going to start. It's like a marathon. This thing is so tough. All right. So this is the calculator section. We got 38 questions. We've got 55 minutes to knock these out. Ready, set, begin. All right. The graph to the left shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for 30 minutes during her hike to have lunch. Based on the graph, which of the following is the closest? It's the time she finished lunch and continued her hike. Here's where she stopped. Boom. This means she stops, right? Because it's just flat line. So she probably finishes her lunch, and that's about 30 minutes, it looks like. So maybe like 1:45 or something, or 1:40. The table to the left shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under the age 40 or male? Female under 40, boom, is 8. Or male 40 or older, males 40 or older, 2. When they say or, we're adding this or this, so it's 10 out of a total of 25. That's it. Let me just make sure I understood that right. Female under age 40, 8, and male over 20, over 40, male over 40. Yeah, I think we're good. Question 3. The graph to the left shows the total number of music album sales in millions each year from 1997 to 2009. Based on the graph, which of the following best describes the general trend in music album sales from 1997 to 2009? 1997 to 2009. Sales generally increase each year. What? No, they decreased, right? Because we're going up and then decrease. Sales generally decrease each year since 19. Sales increase until 2000. Yeah, that sounds right. This is 2000 and then generally decreased. Yeah. Oop. The table above shows some values for of the linear function f. Which of the following defines f? All right. All right, so we're just seeing which one of these were. Is it n minus 3? Well, is it always? No, that doesn't work because 1 minus 3, yeah, but 2 minus 3 is negative 1. 2n minus 4, 8 minus 4 is 4, so this one's out because it doesn't work for that last one. 3n minus 5, 4, 3 times 4 is 12 minus 5, 7. 3 times 3 is 9 minus 4, minus 5 is 4. 3 times 2 is 6, minus 5 is 1. 3 times 1 is 3, minus 5 is negative 2. Yeah, it's this one. 12 minus 6. Yeah, that one's right. Okay, cool. At Lincoln High School, approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted into the National Honor Society. If there were 562 juniors and 602 seniors, which of the following is close to the total number of juniors and seniors who were inducted? All right, so 7% of juniors and 5% here. Actually, think I can do this mentally. Maybe that this would be 60.2. So this would be 60% would be 10%. So 30 here about, and 7% would be. Let's just do it. 562 times 0.07 equals 39. So 39, 69. Boom! Right there. Awesome. Next question. Which of the following is the sum of those two polynomials? Well, let's just add them straight up, right? They're nicely lined up for us. That's good. 5x squared minus 2x minus 6. Boom. This becomes 8x squared. This becomes negative 7x. This becomes negative 4. Negative 6 plus 2. 8x squared minus 7x minus 4. Next. 3/5. What is the value of W? 3/5 W equals 4/3. How do we isolate W? Multiply by the reciprocal. That goes to 1. We got to multiply this side by the reciprocal, and that goes to 20 over 9. Eight. The average number of students per classroom at Central High School from 2000 to 2010 can be modeled by the equation this, where x represents the number of years since 2000 and y represents the average number of students per classroom. Got it. Which of the following best describes the meaning of 0.56 in the equation? It's not the total number of students. This 0.56 is the slope. It's the change. Every year there's a change of 0.56. So it sounds like the number of students per classroom is going up by 0.56 every year. The average number, no. The estimated increase in average number of students per, yeah, it's that. And this makes no sense. Between the average, no. It's the change. That's the slope. How much is it changing by each year? Nate walks 25 meters in 13.7 seconds. 25 meters in 13.7 seconds. If he walks at the same rate, which of the following is closest distance he will walk in 4 minutes? Well, let's set up a proportion. So these two, 25 and 13.7 seconds, 4 minutes. So we want this in seconds too. 4 minutes is 4 times 60, which is 240 seconds. How far will he go? Let's cross multiply. 13.7x equals 25 times 240, which equals 6,000. Divide both sides by 13.7. 6,000 divided by 13.7 equals 430. It's about 450. Boom. Okay, next question. The chart above shows approximations of the acceleration due to gravity in meters per second squared. Yeah, for 8 planets. Well, the weight of an object can be found by using this, where W is the weight of the object measured in newtons, M is the mass, and G is the acceleration due to gravity. What is the weight in newtons of an object on Mercury? Mass of 90 kilograms. So we've got weight equals mass, which is 90, times G, and it's on Mercury, the gravity of Mercury, which is... Wait, where is it? Gravity on Mercury. Right there, 3.6. Oops. So it's just this multiplication. So it's 270 plus 54 is 324. Boom, done. And then I just did the multiplication. And then an object on Earth has a weight of 150 newtons. On which planet would the same object have an approximate weight of 170 newtons? Okay. So we need to find the mass. So 150 weight equals G on Earth, which is 9.8. I'm just filling out the equation, right? Which is W equals mg. So on Earth, the weight is 150. It's 9.8, and then times the grams, which we need to find. Oh, wait, no. Did I do this right? No, sorry, the mass. This is the mass, excuse me. Okay, divide both sides by 9.8. Divide both sides by 9.8. 150 divided by 9.8 equals 15.3. So the mass is 15.3 kilograms. And then we plug that in to, so where would we get 170 newtons? So 170 newtons equals 15.3 times G. And then we're solving for G. 170 divided by 15.3. 15.3 equal, oops. 170 divided by 15.3 equals 11. 11.11. That's the gravity. Which one has 11.1? Saturn. Boom. Makes sense? I'm just plugging in stuff to the equation and working backwards in a sense. That's all I'm doing. Okay. And the function has 5 distinct zeros. Which of the following could represent the complete graph of f? Which of the following basically hits the x-axis 5 times? That's all this is asking. 1, 2, 3, 4. That would be 5 zeros. This is 4 zeros. A is out. 1, 2, 3, 4. No, that's 4 zeros. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5. Done.